So the last section was about calculating molar mass, and now we're going to look at how we can use molar mass as a conversion factor. Because since they are moles per gram, or grams per mole, we have a pair of conversion factors that we can use. So now we can do something like if we have a container of table salt here that contains 737 grams of NaCl, we can figure out how many moles of NaCl are there. And so to do this, we're going to need grams of NaCl down here, and we're going to need moles of NaCl up here. The number that goes with moles is 1 for now. The grams of NaCl, well, this is a molar mass from the periodic table. It's 22.99 times 1 plus 35.45 times 1, and that comes out to be 58.44 grams of NaCl, so 58.44 our grams of NaCl cancel out, and we're left with moles of NaCl. And so that comes out to be 12.6 moles of NaCl. Two things I'll point out here. One, I frequently just do this math right here and don't actually take the time to calculate it out separately and then insert it into my equation. I just put it right there in the equation. You have to be careful when you go to type that into a calculator that you use parentheses properly, but it works out if you do. Also, we could go a step further and we could actually calculate number of molecules if we didn't want to stop there. And so, just like before, we know that 1 mole of NaCl has Avogadro's number worth of technically formula units. I know I said molecules a moment ago. It's essentially the same thing. It just has to do with that repeating pattern that comes up on ionic bonding. But we multiply that by Avogadro's number and we would get the number of pieces there. We could even go out another step, though your textbook doesn't tend to have you do calculations that involve this many ratios, or they'll have you stop and then they'll have you resume it again. But we could take that a step further, and I know the blue's not showing up great on the blue there, so I'm going to pop over here. We could do that 1 formula unit of NaCl has 1 Na atom in it, or we could do 1 Cl atom in it, or we could even say total number of atoms is 1 Na and 1 Cl, so 2 atoms total. And we could do each of those. I'll leave it as a challenge to you to actually punch those in, but this is the real power of, again, moles and molar mass. Now, having said that, even though we use Avogadro's number a decent amount, frequently, for comparison purposes, we can stop at moles. I described moles as the middleman, and there's a flowchart here in a moment that will kind of explain that, but it makes it such that we don't usually have to go out to calculate an individual number of pieces. One more example here, 59.8 grams of water, and we want to know how many moles, and so that's a mass of water, and the question is how many moles, and so we know that we're going to need grams in the denominator here. We're going to need moles in the numerator. The number that goes with moles is 1. And like I said, I frequently will do the mass all in one step here. It's 1.01 times 2 for the hydrogen plus 16 times 1 for the oxygen. And the parentheses aren't necessary there because of order of operations. Like I said, it's just the thing I do to keep track of it. Having said that, if you're punching this into your calculator, you do need a parentheses surrounding the whole thing, or it won't follow order of operations properly. And so you do that, but then you can just punch it in and all in one go. And in the end, you will get 3.32 moles of H2O. As a side note, if you did want to work this one out separately, or you want to check your work, if you were working it out separately, the molar mass of water is 18.02 if we're rounding hydrogen off to 0.01. As I mentioned a moment ago, there is a flowchart here, and you'll see that the flowchart takes you through a variety of different conversions that we can do. Earlier in a prior section, I actually went from moles of a compound, and I went this way to get to number of atoms, and I also went this way to get to number of atoms. And so I showed you the two different ways you could work it out. It turns out that we can do the same thing here, and we can do it with individual elements or whole compounds. And again, that could be molecules, that could be formula units, etc., etc. But we have all of these, and we can go back and forth between them in one direction. Going from grams to moles, for example, you end up with grams grams here, and so then you need the ratio that has moles in the numerator and grams in the denominator if you want to go to the right. If you're wanting to go to the left, that one gets flipped because you'd be starting with moles here, and then I know normally we set up the calculation to the right, but you would be putting moles in the denominator to cancel out and grams up here in the numerator to get to grams there if you're wanting to go that direction. But we have now all of these different ones. Doing dimensional analysis, keeping track of your units, you should have no problem doing this. Having said that, if you find you're struggling with these calculations, this flowchart is decent and might be worth taking up some space on your note card when it comes test time. Certainly, you might want to have it handy as you're practicing and learning it and getting used to it with homework and other assignments. I do think there's a flowchart later on that brings in the extra step that we use for chemical reactions. You'll notice that right now, as I mentioned, moles is in the center here and is kind of our middleman to go from pieces to mass. However, it also turns out that moles is our middleman when we have a chemical reaction and we have substance A reacting with substance B, and we want to go from the amount of one substance to the amount of a different substance. We can also do that here as well. Moles really serves as the middleman for going from one substance to another. In fact, we can't go from mass to the other substance. We have to go through the middleman of moles to get there. I think there's a flowchart for that later on, and that flowchart should have all of this as well as that extra step, and that would be the better one to actually jot down in the long run, but more on that in future sections. And if the textbook happens to not have one made up for you already, I'll draw one up on a blank slide to show you. Anyway, that finishes section 3.